Hello, my name is Luke, creator of Divine Star Software. I've been working on a TypeScript-based voxel engine for the last few years called Divine Voxel Engine. I recently released a game made with it called Crystalline Bliss. It's still in beta, but will keep growing into something more. But today I wanted to show you how to make a simple Minecraft Quest game with my voxel engine and show some of the new features that I'm working on. The code is available on GitHub, so do not worry about copying anything from this video. I wanted to make this video because the engine is finally moving out of alpha into beta. The APIs and design philosophy are much more solidified and coherent. And I want to make more of an effort to show what the engine can do and encourage people to build projects with it. I am leading that way with Crystalline Bliss, but every new developer needs to start somewhere, so this example game here is a great place for people to get started. Alright, so jumping right into this project, we need to figure out which packages from Divine Voxel Engine do we actually need. Divine Voxel Engine is actually a collection of packages that do separate things and are for different projects. The Voxel Engine is expanding beyond Minecraft style worlds, so the actual package to do Minecraft style games now is under Divine Voxel Foundation. Later in the future, there's going to be other packages to do other things. Right now, the only other one that is kind of like Foundation is Divine Voxel Magic, which is handling magic voxel scenes, which I'm still working on. But later in the future, I'm going to be working on one called Divine Voxel Alchemy for doing dual contouring and marching cubes. So look up for that. But there's going to be example games for each in the future. But for now, for this game, we just need Divine Voxel Foundation and Divine Voxel Babylon Renderer. That's all we have to worry about. Okay, jumping right into it, we need to install these packages. So the ones underneath the Divine Star scope are so that I can have easy access to the types, but usually the Divine Voxel packages themselves rely on most of the Divine Star packages, except for Divine Star Audio, which if you want to provide your own audio solution, you can. But these are also packages made by me that are just abstract enough that they should just be in their own package. For instance, the threads, which is handle multi-threading. So I already have a package or initialized here, so I'm just going to go and install all these here. I already made a command for it. All right, so the next packages we have to install are these ones. These are just the dev dependencies for Webpack and TypeScript. I will just install these and then I will show you the Webpack config and go in from there. So here we are looking at the dev Webpack config, which we're mostly concerned about for this video. As you can see, pretty much everything is just normally set up. We have it resolving JSX and TSX files. And then here at the bottom is something that I really need to point out before we go much further, is that the engine requires, or at least Foundation requires, if you're doing multi-threading, to have these headers set when serving the files. Now this makes things pretty difficult when you're trying to serve files from other places, or fetch anything from any other place other than the current origin you're on, because these headers basically block all cross-origin opening and fetching and stuff. You can still do a lot of stuff with WebSockets. My game, Crystalline Bliss, I communicate directly with a web server that's external through WebSockets. So it is still possible to do communication, but it's very hard to load assets or do anything else or embed into another service. So that is one caveat with multi-threading. And I've looked into other solutions with WASM and all that, but WASM still relies on shared array buffers to do multi-threading. So there's no really escaping the reality of doing that. So, and without multi-threading, the performance is usually so bad it's not even worth it. So, but anyway, this needs to be separate to dev server. And this is the very latest Webpack. So this is what this looks like. So this is all I just wanted to point in here. So next we can start actually adding files and doing all that. I got the project structure started here. The static folder is just for assets, and the source folder is for all the program files. I just got a normal tsconfig file here, a normal React setup, just grabbing the root element and rendering the application to it. And then here in the app itself, we have a canvas that we're grabbing a reference to because we're going to be rendering to it later. And then I'm starting to create the workers. So these workers we will have to pass to the engine. And these are all coming from the context folder, which I'm going to go over now. So the world thread, the world worker, whatever you want to call it, handles data syncing data mapping, all that kind of stuff. So we just import the default start world function from Foundation. What this does, it just basically just makes it easy to initialize Divine Voxel Engine world, which is just the name of the class that we get passed back, and the Foundation core. And this function, we have the passive voxel data, which I'm not going to worry about now. I'll show you later. And then we have to tell it that Nexus is enabled, which I will tell you what the Nexus is now. The Nexus thread is a thread just for doing anything you want, but in this case, we're going to be using it for running physics. It just gives you access to the world data in a thread that is completely separate from anything else. So we're just importing Divine Voxel Engine Nexus from Foundation because it is a special context just from Foundation. And then we're importing the data core, which tells the engine how to interpret the data, and that's also from Foundation. And we just initialize it. And then finally, the constructor thread, which handles everything from light updates to meshing and all that stuff. It has another just default start function, and then the builder here will worry about that a bit, but this gives us access to the default voxel shapes. And yeah, here we also have to pass it something to describe voxels, but this is voxel constructors, which tell the engine actually how to build the voxels. So, but with these all built, we can import them here and create the workers and start actually initializing the engine. Now that we have everything ready to go, we can start importing the stuff we need and start initializing everything. So from Divine Voxel Engine, we're actually going to have to import some stuff from Babylon Renderer. We're going to pull from defaults the classic initialization. So what this will do is initialize the engine with the original material pipeline. But I will show you at the end of the video, I am working on a new rendering pipeline using PPR. But for now, I'm just going to show classic. And then we need the core. This is the foundation core. The core just handles extra threads and data and stuff like that. It's just something that the main voxel engine itself needs to interpret what's going on. And then we import the scene tool, which is an extra tool from Foundation, which basically helps us update a bunch of materials at once. And then we import the stuff we need from Babylon, which is the scene, engine, a camera, vector, and a sphere for the skybox. So here we're doing nothing too special. We're just initializing a basic Babylon scene. We grab the canvas from the ref to it. And then one thing we do is we add a event listener for click on window. So when user clicks on the window, we request a pointer lock. What this will let us do is lock the pointer to the canvas so that we get first-person controls like MineCraft. And then we create a scene in the camera, do all that stuff. We started rendering it. And then we started initializing the actual Divine Voxel Engine. We create a new instance of Divine Voxel Engine renderer. And then we initialize the actual renderer here, so we get passed back the Babylon renderer. And then with that, we can initialize the core. And with the renderer and the core, we can initialize the engine. So the thing we have to pass to the renderer is the actual texture data, which I will show off all that next. But one thing to note here is after everything is initialized, I just grab the material from the materials register for the skybox and I attach it to my custom skybox. And then I add, or I change the settings for the scene with the scene tool. So here I'm saying that we're going to be using sunlight shading, and doing AO. So this is all information that is baked into the meshes. So this is all going to be baked into the meshes and the materials are going to account for it. And then I set the basic level for that. So I'm saying that the sun level is 0.8. Then also I set the fog color and density. Right. So from there we can start actually adding voxel data. Alright, before I go much further, I want to say I'm going to be using textures from Pixel Perfection. This is a really nice resource pack, but I'm using an older version from 1.12. So it's from an older version of MineCraft. but it's open source by them. Xsheep, don't know how to properly pronounce it, but just wanted to shout them out. I think they look really beautiful. I'm pretty sure I played mod packs with textures with this resource pack before. It looks really good. Just wanted to shout them out. Most everything, or 99% of everything in this channel, texture-wise or music-wise, I make by myself. Anything that is not explicitly mine, I will point out. But yeah, so I just wanted to make something that wasn't my art style, and I didn't want to have to worry about remaking all of Minecraft textures by hand just for this one project. So shout out to them. This is really beautiful work. I really love these textures, and it's really awesome to use them for this project. All right, now we can start actually getting data into the game. So the first thing we're going to do is register all the textures. So to do that, we're going to create a new file called texture data, create a new folder called data. This is just where I'm going to keep stuff. So the first thing we have to do is import the type of texture data from Foundation. So just Divine Voxel Foundation textures. And then the texture manager, we're just going to tell it where the default texture path is. So in this case, it's asset textures. Next, we're going to register all the textures, and I need to explain what's actually going on here because it might be a little confusing. So the type is basically the outputting final texture where it's going to be put. All the textures are stitched together into one final 2D array texture. So the type is basically just the ID of that final texture. So that is used to build materials. So every solid like voxel that's of the same material has to have the DV solid type. And every type that is the glowing type has to be DV glow. And then every type that is underneath flora has to be underneath DV flora. And then every type that's part of liquid has to be part of DV liquid. So this is just a name tag. This is something that Minecraft uses too, but I'm using it here just because it makes it easier for people to add custom things. And you see here, I'm just naming the textures the name of the voxel that they're associated with. So I'm also scoping the voxels with Divine.Craft. So Divine.Craft glass block, grass block, Divine.Craft glowstone, Divine.Craft cobblestone, all that. So then here we can also add variations. So the variations are just named other textures. So just the way that the texture manager usually works is that it grabs or it looks for a folder with the name of the ID, and then it grabs an image called default underneath. So here is the static folder, and I have asset textures, and I got basically all the textures set up like we need. So Divine.Craft dirt, there's a default PNG, and we're using the texture from Pixel Perfect. So all these are set up correctly. So here in the grass block, we have the default picture, which is just the top, and then the side variation, which is the side, and the bottom variation. So, as you can see here, there's frames. This is because we can do animated textures, but I'm not going to go into that now. So you just have to tell if it's not animated that it has no frames. Now, this is not the only way to load textures. There is a more advanced way that my game uses where you can bundle stuff and just pass in raw data, but I won't go into that now. So with that, like I showed earlier, we can pass in the texture data to here in a DVR renderer, and then it'll stitch everything together for us, and we can go from there. So the next thing we need to do is register the voxel data. So it's a little bit more complicated, but it is pretty simple. So each voxel gets an ID, and then each voxel has a set of associated tags that will affect its behavior in the engine. So these tags get compiled down into binary data, and there's only one set of keys and a set of index. So everything is automatically mapped, and it makes it easier to share things like with the GPU and all that. So all you really need to know is just the basic tags that you need to set to do what you want. So for this cobblestone, we give it a substance to dv solid. We give it a shape ID of dv box. So this just knows how to do calling when it's creating the meshes. And then since we're doing physics, we could give it a collider ID of a box, and we tell it to check collisions. And then we assign a material of stone, and this is good for things like sound design. So we do that for all the voxels that we need to. So I'm just going to point out the special ones. Like the glowstone, we give it a light value of 15, 15, 15. So this will make it a white light. Divine Voxel Engine does RGB light with a value of 0 to 15. So you can do red, green, blue lights, different color lights, but we're just going to make it a white light like it is in Minecraft. And then here we assign the oak leaves to be a type of, or a substance type of flora. And then we assign the water to be a substance type of liquid. So this will tell it to actually flow if you place it down, if it's a substance type of liquid. You can add custom substance types with their own properties and all that stuff, but I'm not going to go into that in this video, but that is another powerful thing. So after we have the data set up for the voxels, we import it here and pass it here. Well, the next thing I want to show, that's in the world thread. But the next thing I want to show is the constructors for the constructor thread. So what this does is actually define how to build the voxels. So here, the grass block, we're telling it it's a simple box, but then we're giving it the exact textures to use for every side of the face. So what this array is basically a texture lookup. It's going to look for this texture type and then this texture and then get its index. And we can also pass in the variation. So if you don't give it a third entry here, it's just going to use the default texture. But if you give it the third entry, you can use the variations. So you can see here we're just assigning all the voxels to their appropriate constructors. So here, note that we're assigning the liquid constructor to the water voxel. And then we are making the glowstone voxel pull from the glowstone, from the glowing substance for its texture. Those are only two big things to note. But there's different shapes that you can use, and I will be showing them off in the future, especially used for plants and stairs and all that kind of stuff. But now we're only just concerned with boxes and water. All right, so after all this is set up, we can start getting the player in. Okay, to actually get started with the player, I am not going to write it all from scratch because it would take me a very long time to show that off. So I'm going to be using code from the starter app, which is basically actually a set of apps that I am making that just make it easy to get started, but I am providing some player code that just make it easy to get started. So I'm going to get that integrated, and then I'll show it off from there. All right, so the game is loading, and it's just going to take a second just to do all the sunlight propagation, and here we are in our game. Now if I left click, I can place cobblestone. Makes my life pretty easy. And you can see we're just experiencing the world with the classic shaders. Everything looks like old school Minecraft. I will show how I do the world generation in a second. This isn't anything too special, just something very simple, but we can break blocks, we can place blocks. Water you fall slowly in. Yep, and the world has an edge, just like Minecraft Classic does. Eventually, I will show up a video how to make infinite world generation. There is actually a part of the code to do that, but this video is already pretty long, so yeah. So now I just wanted to show off how the actual code works for the world generation, and then after that, I will show off the world with the PPR renderer. Alright, so now jumping back into the code, let's look at how the world generation actually works. And the first I want to point out that this start world task is actually called in the app component before init render player. But getting right into it, you can see that we are defining the bounds of the world and then looping through it in iterations the size of a chunk or a column's width and depth. So I just want to explain what's actually going on because this is just a little complicated. And I'll explain what the world gen class does in a second after all this. So we are grabbing two tools from the core, from the foundation world core. The first one is the builder tool, which lets us build columns and chunks and lets us do other things in the world. And the task tool, which lets us do multi-threaded tasks, such as sunlight updates, light updates, water flow, all that kind of stuff. And the most kind of convoluted thing that's going on here is the set focal point. So Divine Voxel Engine is actually multi-dimensional. You can have as many dimensions as you want, but you have to tell the task tool what dimension you're working in first, and the default dimension is called main. So here we're setting the focal point to be main at 0, 0, 0. And then we're looping through all the columns that we're going to be generating, and we're filling the columns with empty chunks from the builder tool. Now you can have regions and stuff on top of each other. It doesn't necessarily have to be all in the XZ plane, but it makes stuff a lot more complicated for other things. So just for this example, it's just the XZ columns. And then with the world gen, we call 3 functions. The first one, generate world column, generates the world and basically carves, caves into it while it's generating. The fill world column fills it with either sand or water, depending on what biome it is. And then the decorate world column adds like trees and grass and all that. And then with the task tool, we're adding the chunk or the column to the specific task. The first one is propagation, which handles all things from water to light and all that. And then world sun, which has its own special thing just for world sun, like Minecraft style world sun propagation. And then here we're waiting these tasks to be done. So this is all, so when it runs, all the tasks that were queued get dispersed to the threads and we wait for it to finish. And then after all that is done, we loop through the world again and build all the columns. Now after that is all done, we init the world player. So looking at world gen, this is a little simple. World gen is not very advanced. I didn't want to spend a crazy amount of time doing this, but I think as the Minecraft, this tutorial example evolves, it'll get more complicated. But the important thing to note from here is that we're pulling Perlin Noise 3D from Divine Star RNG. So this gives us access to Perlin Noise. So we're using this Perlin just for the world generation and this biome Perlin for biomes. And then we have this enum biomes, ocean, beach, and grassland. And then we have this get biome function, which is have an XYZ. And from that, we determine a biome based off the value and like a given range. And then I use a beach to just kind of buffer the zones between grassland and beaches. I mean, grasslands and oceans. And then this noise height function determines like the actual height of the world that's going to be generated. And then this in noise range function is a little bit more complicated. It basically carves the world. So the noise height is going to be given by this, but the ultimate result and what's carved out of it is going to be from here. So, and then looking at the explicit functions, generate world column, fill world column, and decorate world column. They're all going to be using the brush tool. And in this case, I'm using the advanced brush tool, which is only available in the world thread, but this basically, there's nothing special about it other than if you want to do direct updates that are immediately updated, like for the player, you can do that, or just be used as a normal brush tool. But a brush, you can think of it as like an actual paintbrush. You pick the color you want to paint with, and then you paint the canvas with it. So in this case, we set the ID, which is basically the paint, and we tell it where to go, and then we tell it to literally paint. And so then it'll place a voxel there. So this can be kind of nice. So if you only need to set the ID once, you can set the ID once and just keep setting the XYZ where it needs to be. But the brush tool is really simple. And the other tool that is used is the data tool, which the brush tool is actually built from the data tool, but the data tool gives you direct access to the world data and lets you work with it and read it and update it directly. But the data tool is used by the fill world column just to determine if it can add stuff and if it can, for the decorate world column, if it can change stuff into grass and add trees and all that. So the data tool, you have to load in to make sure it can be loaded in. You have to load it in first. And then after that, you can actually grab the data from it. So the data tool just has a lot of functions. Like data tool is air, is barrier, is light source, is opaque. And then you can set the level, set light, all this more advanced stuff. It's not stuff you have to worry about, but just here you can see it's just very simple. We're just grabbing the string ID of the voxel just to make sure it's stone. If it is stone, turn it into grass and do all that. The only really convoluted and kind of complicated thing that probably would not make sense is this brush start, brush stop thing. Now, what this does is makes it run faster. So before you do massive amount of work, like this bigger iteration through the whole column, the whole world column, this will enable lookup caching. So when looking up a voxel in the world, it has to do 3 levels of caching because the world is stored in dimensions, then regions, then columns, then chunks. What this will do is just store locally the chunk lookups and just make it easier. So it will temporarily store stuff so it doesn't have to do all 3 levels of hashing. And doing this actually sped up a lot of things. So just make sure, if you see some stuff running slow, make sure you have brush start and brush stop beforehand. Okay. And like I said, or I shown earlier, with the world gen tool, we're just using it here with generate world column, fill world column, and decorate world column. All right. So the last thing I'm going to do before I show off the PPR material is just add a Voxel Select component, and then I'll just talk about it, and then we'll look at the awesome PPR rendering. All right, as you can see here, I added a Voxel Select component is nothing too impressive, but it's just, it loops over the voxel data, gets the player's selected voxel, and lets the player select a different voxel. Here, just in the player state, you can see that it's just as a function to get the next voxel, so it's literally going through the voxel data that we have, and then notifying through an observer that it's been updated, and setting the state here, and then and the setup controls here, just adding something to the wheel. So it's going down, we go left, if it's up, it's right. All right. And then, of course, with that, we have it all ready to go. So you're probably making a real game. You would probably do something more complicated, but just for this demo, it's good enough, I think. You can place the lights, do all that. Okay, I think next I really want to show off how everything looks with the PPR material and show how to set that up. All right, to get the actual PPR rendering pipeline working properly, we had to provide a skybox. So I just added this to the root of my assets here. So the skybox HDR file for the skybox. I will probably be updating this in the future. Like I said, the PPR is still experimental. And then we just have to change what it's importing. So instead of the init classic, we're going to init dv PPR. And then I'm going to comment out this skybox because PPR comes with its own custom skybox. And here we can see it loading. All right. So let's go check out the world. Looks pretty nice. It's not perfect, but like I said, I'm working on this. It really makes all the textures pop, all the real-time shadows is pretty nice. The water is pretty decent. It still needs a bit of work, but it's getting there. But this is all using the Babylon materials and rendering pipelines. It almost looks like a completely different game. But yeah. So I really hope you enjoyed watching this and you're excited just to build stuff. Doesn't have to be with my engine. Just I hope you are inspired to, just have fun and just do whatever you want. Because that's what I'm doing. I don't know. I think some people just, they take stuff, life a little too seriously and they forget to have fun and just You know, I think that's why I really like voxels, because they're very innocent, they're very mathematically pure. That makes sense. There's just not a lot of fuzziness. There's a lot of certainty with voxels. You know, it just kind of just takes you back to being a kid, and I think in a good way. And what I would really like to see is just more voxel games that aren't necessarily just Minecraft. I want to see just a flourishing of voxel games, all different types of voxel games, and any size, any shape, doesn't matter. I love voxels anyway. You know, just, be happy, have fun. Well, thank you so much for watching, and if you liked this and you want me to make more tutorial videos, or if you want me just to talk more and do more stuff like this, please let me know. If you want to support the channel and support Divine Star, you can always buy my game and just share this video with people that you know that would be interested in this and want to build games with TypeScript and all that. So thank you for watching, and I will see you in the next video.